Hello. This is a continuation from my theoretical explanation of the open drain AND gate. This time I'll be explaining how they work exactly. So let's say we have two of these things. Let me make that better. Oh, this is wired up here. This is how you would normally connect these things because, once again, open drains, oh, this one's open drain too, does not have any power. So, this may be difficult to realize how these work, but unlike regular NAND gates where they just simply put out a 0, these things actually suck in the power, which will affect the entire output line for both of these. And has actually involved a little bit of research on my part to figure out what this was equivalent to. And so let's figure out how these things will affect the output. So instead of comparing these nodes, we'll be comparing the gates themselves. So we'll label this one 1, this one 2. 0, 0, 0, 1. So let's figure this out. So if the output of these are both 0, well, then the output's going to be 0. Okay. And then now when the output of this is 1, and the output of this is 0, it's going to be 0. Likewise for that. The only time when it's out, the only time when these things are 1, 1, and the only time when the 5 volts can actually go out is when this happens. So, upon further analysis, this pretty much is equivalent to this. And these will be regular NAND gates. So let's see if this is actually equivalent or not. Let's check it out. And please note, you may not want to do this on your own. This is just a way to understand how the logic of this works. Just distinct those a bit. There we go. And we'll just call these 1 and 2. Notice these are regular NAND gates, no OD symbol next to them. Okay, so when these are both 0, it's going to be 0. I realized I made a mistake. This is in fact a AND gate logic output as opposed to an OR gate, so it should be not this, but that. Sorry. So, if we complete the logic where both of these outputs will be 0, and then 0, and when they will be 1, the AND gate will realize that it's a 1 as well. Sorry about that. So we can finally conclude, without making any errors, that the wired logic, and let's make 3 of these, be a little creative. Is completely equal, logic-wise, to this. And from this perspective, it is now much easier to see how this works. And the fact that not many people normally think this is like an OR gate, but really it's not. All of these have to be closed off from ground in order to have the output to 1, so therefore it is not an OR gate at all, more like an AND gate. Otherwise, if only one of these things opens up to the ground, this will just be 0, and these won't be pretty much completely irrelevant. And well, the same. And if you realize this, it's pretty much the same case here. I hope this helps, and thank you for your time.